Now that we've finished talking about distributions, we are going to start talking about how we estimate a population parameter giving sample statistics. So first, we're going to talk about how we estimate a population proportion. So, of course, we need some definitions. So a point estimate is the value of a statistic that estimates the value of a parameter. In other words, we're going to use sample data to find the value of a statistic, which can then be used to estimate the corresponding population parameter. So because we're using sample data to estimate what a population parameter is, we're now using inferential statistics. So to estimate the population proportion, which is denoted by the letter P, we use the sample proportion. And the sample proportion is given by this formula. P hat, which is the sample proportion, equals X divided by N. Now, X is the number of individuals in the sample who have the specified characteristic, and N, of course, is the sample size, just like always. Note, when we do these, we always sort of agree to round our proportions. So P hat and P, we're going to round to 3 decimal places. So let's look at an example. The Gallup organization conducted a poll in which a simple random sample of 1,016 Americans 18 and older were asked, do you consider the amount of federal income tax you have to pay to be fair? Of the 1,016 adult Americans surveyed, 558 said yes. Obtain the point estimate for the proportion of Americans aged 18 and older who believe the amount of federal income tax they pay is fair. So remember, P hat, our sample proportion, is X divided by N. X is the number of people that have the characteristic. In other words, say the amount they pay is fair. So 558 over the total number of people we surveyed. And if we do that and round to 3 decimal places, we get 0.549. So we estimate that 54.9% of adult Americans, and we'll just say aged 18 or older, believe the amount of federal income tax they pay is fair. Now, that's all well and good as an estimate, but we don't like to just give an estimate like that. What we need is an entire confidence interval. So let's talk about what a confidence interval is. So the idea of a confidence interval is using the sample proportion, remember that's p hat, to estimate the population proportion. And it can be problematic to do that. Why? Well, every sample we take is different. So that was one sample we did above, but if we had a different sample, we would probably get a different value for p hat. So to compensate for that issue, we report a range or interval of values. And we also include a measure of the confidence we have that the interval includes the unknown population proportion. So for example, if we survey 80 Rhone State students and find that 60 of them use Facebook, we might conclude that p hat, which remember is x over n, or 60 over 80, or 0.75, or 75%, right, of all Rhone State students use Facebook. But we didn't survey all students. We only surveyed 80 students. So our estimate might be wrong. So to account for that possible error, we might say the proportion of Rhone State students who uses Facebook is 0.75, give or take 0.05. The 0.05 in this instance is what we call the margin of error. So mathematically, we would write the estimate as 0.75 plus or minus 0.05, meaning that the population proportion is between 0.75 minus 0.05, which is 0.70, and between 0.75 plus 0.05, which is 0.80. So that's better. Now we have a range of values, but we also need to say how confident we are that the population proportion is between those two values. So one thing to note here, the more confident we are, the wider our confidence interval will be. And by wider, we mean that the distance between the lower bound and the upper bound will be greater. So that's the idea behind this. When we start the next video, we'll talk about some more definitions we need to be able to talk about these intervals.